I want to show how to do Lab 2, and I have up on the screen here my instructions. I want to see if I can follow them. I have the probability of certain teams winning a game, which is the probability of success for this binomial distribution. The 82 game season means N, the number of trials is 82, and we're going to use StatCrunch to calculate a binomial probability for each of these teams, and I want to show how to do that. So it says click on Stat, calculator is binomial. So the first thing I want to do is go into StatCrunch. Let me see. So this is like what my home page looks like. Yours probably looks similar. I'm going into My Lab and Mastering. I'm going to go down here, the course home, I guess. And then on the left side of the screen, I'm going to go into StatCrunch. Okay, so there's StatCrunch, and we're not going to use a data set from our book. We're going to go to the StatCrunch website. Okay, we're going to open StatCrunch. Okay, so we have StatCrunch opened. Now let me see, what does it say to do? Click Stat, Calculators, Binomial. So click Stat, Calculators, Binomial. Okay, there's the binomial calculator. There's what it looked like. So you should get something that looks like that coming up on your screen. Let's see. So there's that picture that I was just talking about. And then for each team, enter n equals 82. So I'm going to enter n equals 82. Notice I'm using the standard calculator here. N equals 82. And then for the P, that's the probability of success. It defaults to 0.5, but you want to enter the probability from the team that you're doing. Since I want you to do that, I'm going to enter what I'm talking about are these different probabilities. When you're doing the Bruins, enter 0.4, the Sabres 0.45, etc. So I don't want to do one of those. So for the purpose of this demonstration, I'm going to use 0.42 as the probability, just to show what's going on. So I'm entering 0.42 for the probability. And then I want the probability that the team wins greater than or equal to 45 games, I think is what it says. Yeah, the probability that it's greater than, that X, the number of successes or wins, is greater than or equal to 45. So it says the symbol there is from the drop-down menu. Let's see. So here's the drop-down menu that I'm talking about, and I want greater than or equal to, and I want 45 here. And then when I hit compute, it'll give me the probability. So here's the nice little normal looking graph. The red part corresponds to the part that's greater than or equal to 45. And here's the probability here, this 0.012666938. So that's the probability that a team with a winning percentage or probability of success of 0.42 wins at least 45 games out of an 82 game season is about 0.013 if it's rounded off to 3 decimal places. So let me see what my instructions say. Okay, so you want to print out that image or take a picture of it. You want to do one for each team. And the questions ask, find the probability that X is greater than or equal to 45. So for part A, that answer is that 0.013. Now to calculate the mean of the distribution, now down here I have a little picture of how I calculated that. So this part A is just this number, this 0.013 rounded off to 3 decimal places. The mean of a binomial distribution is the number of trials, which is this 82, times the probability of success, which is this 42. So just to show on the calculator, if I go 82 times 0.42, enter. So that's that 34.44 that I'm getting. So that's where that 34.44 goes. Now the standard deviation for a binomial distribution, sigma, is the square root of n, the number of trials, p, the probability of success, and remember q is 1 minus p. So in this case, the q is 1 minus 0.42. Let me see, so just the q, just to show, it's 1 minus 0.42, 0.58. That's where that 0.58 is coming from. So the square root of NPQ is the square root of 82 times 0.42, and the 1 minus 0.42 is that 0.58. And if I do that on the calculator, I get the square root of 82 times 0.42 times 0.58. I'm going to close off the square root parentheses, enter. 4.47 if I round that off to 2 decimal places. So that's where I'm getting that 4.47 from. And then you want to calculate the range of significant values, the range of non-significant values is 2 standard deviations below and above the mean. The mean was 34.44. The standard deviation was 4.47. So mu minus 2 sigma would be 34.44 minus 2 times 4.47. So it's 34.44. 34.44 minus 2 times 4.47. This is the lower edge. That's the 25.5. So that's where this 25.5 is coming from. And then mu plus 2 sigma on the calculator would be the 34.44 plus 2 times 4.47, 43. Did I do that right? I guess so, 43.38. Wonder if I rounded that off. Let's see, 43. Well, I guess I round that off to one place, 43.4. And then the question E, the last question, so there was, I did A, B, C, the range of non-significant values. Is 45 significant? So to be significant, 45 would have to be either less than 25.5, which it's not, or greater than 43.4, which it is. So my answer is x equals 45 is significant. Now I want you to answer these questions A, B, C, D, E for each team, and I want you to do exactly what I just showed. And remember, what I just showed, I used the probability of success as 0.42. I want you to do the same thing for each of these teams, but when you're doing the Bruins, enter the probability of success as 0.4, for the Sabres as 0.45, etc. You should have 5 of these things. So you can either, I think when I made this up, I kind of printed out the chart and wrote this out on the printout. You don't have to print it out. You can, because we're not doing face-to-face, you can just take a picture of this chart or copy the image onto the computer and then show these calculations on a separate paper, one for each team. However you want to submit it is okay with me. If you have any questions, you can come to my office hour. You can ask a question on the discussion. If you submit the lab early, I will be happy to give you some constructive feedback and an opportunity to improve your grade.